So we're going to look at patterns with toys, patterns with figures, patterns with geometry. So we previously looked at a pattern like number 1. There's another video here that does a pattern like number 2. And in a previous session, we did a problem like number 3 with dots instead of triangles. So let's try another pattern like number 2 here and see if we can answer some similar questions on this. Now, in a lot of classrooms, they'll have a set of toys like this that kids can play with to do a little math. And there's lots of research that shows that kids that do hands-on math think about math in different ways than other kids and often do much better. Okay. So I have an app here that we can connect to if you don't happen to have access to a set of toys like this. These are called pattern blocks. And so here's my pattern block app. So I just want to play with these things and use 3 different toys to make a pattern. So I think I'll try triangle. And then extending that, I would add something onto the triangle. So like maybe I'll do triangle and then let's say, no, I don't want to do that one yet. I want to do this one. And to get those 2 to fit together, I'm going to rotate this sucker. There we go. Stick that there. So this is my first stage. This is my second stage. And then to continue, I'm going to group these together and make a copy. Let's see, duplicate down here. And so my third stage, we'll rotate this one on there. So that's my third stage there. And so I'm going to make a couple more just to go with it. So let's group those together and duplicate. And so the pattern I'm trying to get going here is green, blue, red. So green should be next. So we'll tack that on. And let's do one more. And there's 2 ways again to connect these. You can encircle them with your mouse and that'll join them. Or if you click on the first one and do a shift click for each one after that, it'll join them together. Duplicate. And then we need a blue one. Rotated. It's too much. And then they snap together if you get them close enough there. All right, so this is my sequence right there. And so I just want to kind of play around with it and see if I can make predictions, like what's going to be in, what's the 10th figure going to look like? Or if I look at the 200th figure, how many blue rhombuses is it going to have? So to do that, what we found is making tables to keep track of information often helps us see patterns. So let's make a table. First, I want to grab a picture of this one. All right, so there's my first few figures there. Let's make a table. So if I look at the application to kind of get a sense of what kinds of things I want to keep track of, and the second one here, I'm asked to draw the 7th figure. So here I have 1, 2, 3, 4. So if I make a few more figures, what's the 7th one going to look like? Do your best sketch of that. And you could do the sketch in this app and take a screenshot of it. That totally works. Or you could try to draw it on paper. Or if you have the real toys, you can take a picture of it. How many hexagons will be in the 10th figure? So we'll ask a similar question. Which pattern blocks will be at the ends of the 185th? How many of each pattern block will be in the 186th? Okay, so we need to keep track of, say, when is there a hexagon and how many? When is there a trapezoid? How many? When is there a rhombus? How many? So let's start looking for patterns there. So we want a table. And in that table, we want to know which stage we're at. We'll call that N. So this would be stage 1, and that's stage 2, and that's stage 3, and that's stage 4, and that's stage 5. We want to keep track of the total number of figures. What else do we want to keep track of? We'd want to keep track of each of the shapes. So we could have our triangles, our rhombuses, and our hexagons, and that might be enough information. Let's give it a try and see what happens. So in stage 1, there's one figure, and then we have triangles, we have rhombuses, and we have, what are those, trapezoids? Or we could call them green, blue, whoa, right letters, wrong order, and red. So then there's just one green. And the second figure, we have two figures total, 1 and 1. In the third one, we have 3 figures total, and that would be 1 of each. And then in the fourth one, we have 4, and then we get a new triangle. So it's 2, 1, 1. And sometimes I have to go out a ways before I feel comfortable. And even then, I might have to go farther. The fifth figure, there are 5. So the number is pretty straightforward. And then we still have 2 of the greens. Now we have 2 of the blues, but 1 there. So let's make a few more. Sixth row, 6 figures. Still 2 triangles, still 2 blue rhombuses, but we get a red trapezoid. Okay, so I'm starting to see a pattern going on there. Let's go 7, 7. Since I just put the last red trapezoid, I got to backtrack over to here to put another green, but the blue and the red stay fixed. 8, 8, 3, 3, 2. And let's do one more and see if that's enough. 9, 9, 3, 3, and 3. So just to double check my data here, is it true that in the 9th row, 3 plus 3 plus 3 is 9? Yep. 8th row, 3 plus 3 is 6, plus 2 is 8. 7th row, 3 plus 2 is 5, plus 2 is 7. Okay, so my numbers seem pretty consistent here. So last time I did a pattern like this, I decided to highlight some stuff to keep track of it. And I can kind of see it in the table, right? So here we started with the triangle and ended with a triangle. Here we're ending with the trapezoid. Here we're ending, sorry, with the rhombus. Here we're ending with the trapezoid. And then I end with a triangle, end with a rhombus, end with a trapezoid. So there's a nice pattern going on there. So let's break this up a little bit. So, right, we only have 3 shapes and they're alternating in regular order. So I kind of have some lines I could draw in between here with every third one. So if I have a stage that is a 3, a 6, or a 9, it will have ended with a red trapezoid. Right, if I have a stage, so that's pretty straightforward. 3, 6, 9 ends in a trapezoid. Let's write that down. Easy patterns. 3, 6, 9, etc. ends in trapezoid. The rhombuses, let's use some blue highlighting there. Highlighter blue. For the rhombuses, let's see, here I get to add on a rhombus. So this one is a rhombus here in the end, and this one is a rhombus in the end, and this one is a rhombus in the end. So interesting pattern, 2, 5, 8, they're all 3 apart, which makes sense, right? Because we have 1, 2, 3 shapes. Okay, this is starting to shape up here. So for the rhombus, we found that the second one plus 3, the fifth one plus 3, the 8th one ends in a rhombus. Oh, I did not spell that right. There we go. and then 1, 4, 7, etc. is going to end in a triangle. All right, so if we just picked a number like n equals 200, can we describe what this is? So describe this figure. So I got to figure out, is 200 an end in a trapezoid, an end in a rhombus, or an end in a triangle? Now, the trapezoid is pretty straightforward, right? That's just a multiple of 3. So is 200 a multiple of 3? Well, let's check. If we take 3 into 200, 3 goes into 2 0 times, 3 goes into 26, 6 times 3 is 18, subtract, and then I get another 20, 6 times, 18, with 2 left over. Okay. So which of these is related to 2 left over? So 3 goes into 3, 6, or 9 with 0 left over. 3 goes into 2, 5, and 8. Oh, that one right there. This line right here has remainders of 2. Remainder 2. And these guys right here, right? 3 goes into 4 with 1 left over. Once with 1 left over. 3 goes into 7 twice with 1 left over. As far as 3 is concerned, which is the magic number here, these lists, the triangle numbers, have a remainder of 1. All right, so since here I have a remainder of 2, that means this must end in a rhombus. And I'm using R for remainder there, not R for rhombus. Remainder 2 means ends in rhombus. All right, and again, my pattern generally, let's put that here too to think about this some more. Get a snapshot of it. And let's just grab that third one. And shrink it down a little. So here's my pattern. So it's always triangle, rhombus, trapezoid, triangle, rhombus, trapezoid. Okay, so we know it ends in a rhombus. That's a big deal. Everything starts with a triangle. So the 200th figure starts with a triangle. Now I stopped, the 200th figure stops with one of those right there. And because of my remainder, right, I know this is 1, 2 past a multiple of 3. Okay, so how many groups of 3 were before this endpoint? Well, according to my calculation here, 200 is equal to 66 groups of 3 with 2 left over. So that means there should be 66 of these triangles, trapezoids, and rhombuses, followed by a triangle and a rhombus. I don't think I said that right earlier. Let's try that again. So let's see, I'm going to make a copy of this here. Actually, I can just draw it. So there's 66 triangle. Can I draw a trapezoid? There we go. No, that's a rhombus, Gary, you're lying. And then this is the trapezoid there. Okay, so there's 66 of these. And then there's another triangle attached to a rhombus right there. So somebody says, okay, how many triangles are in this figure? So as far as triangles go, I have 66 plus 1, there's 67 of them. As far as rhombuses, there would be 66 of them plus another one, 67. And then we didn't get to add an extra trapezoid, so there's just 66 of those. So trapezoid. So I can pretty much tell you anything about this by just looking at the first few. Trapezoid, there we go. And there's 66. All right, does this add up right? Let's check to see if this adds up right. 7 and 7 is 14 plus 6 is 20. And then 6 and 2 is 8 and 6 is 14 and another 6 is 20. Hey, it adds up to 200. Yeah, so we now have the ability for two reasons. We know it's always triangle, rhombus, trapezoid, and we know when those guys occur in the list. So really, we just have to look for groups of 3, see how many groups of 3 and how many left over there were. So a couple side notes to nail this home, right? We found that there were 66 groups of 3. That's what division tells us, with 2 extra pieces. And we know they're always going to be in this sequence, right? Triangle, rhombus, trapezoid. So no matter what number somebody gives me, like they want me to find what's going on with the 185th figure in this sequence, I can tell you everything about it because I know the patterns of it. And I know the patterns of it because I summarized it in a table. Cool. Power of tables for solving problems.